Mass wasting is simply when the earth and its rock materials move downhill because it's exceeded the angle of repose. So we're going to look at a handful in this virtual field trip. Let's start with creeps. All right, I'm at Glacier National Park, and this is a great shot of what happens when you get creeping. And I'm not talking about people that are creepy, but I'm talking about mass wasting creeping. And I'm going to zoom in a little bit on this tree coming off of this outcrop at Logan's Pass area. It's not quite to the pass, but take a look at this process right there. You can't miss it. Do you see how the trunk has curved and then the tree is pointing up to the sky? What's happening is the rock is actually moving slowly, and because it's moving, the tree needs to get sunlight, and it compensates for it and makes this type of a system that has these bent tree trunks like this. One of the best I've ever seen. So you can get a really good shot of what happens to trees when you get rocks that move. And you're looking at this outcrop. Let's look at the outcrop now. You're like, well, I don't see it moving. It's so imperceptible, you're not going to notice it. Some trees may or may not do it. It could be that that one section is creeping and another section is not. But I'm going to kind of scale the perimeter here, and there's more. As I come around, you're going to see some more this way that are clearly doing the same thing. And you can just see they're not as extreme, but this is the tree's mechanism for trying to compensate for mass wasting. Even though it's slow, and I would imagine at times it's fairly fast out here, there's lots of signage to watch for fallen, not just falling, but fallen rocks. And I would tell you that we just saw some falling in the present tense rocks as we left Logan's Pass. They came behind our car. Had we been there a few seconds later, it would have hit the car. And I was like, wow, I wish I could have gotten that on video, all in the name of science. But nevertheless, this is what creeping looks like. And creeping is a slow process where the earth is actually moving, meeting the soil and the sediment and rock. And this is the tree's mechanism for compensating for such a disaster. While this may be a pretty waterfall, there's actually a best management practice to help reduce mass wasting. They've used natural rocks in the park as an anchor, much like riprap, but they've actually anchored it in place. And a couple things I might point out, I'll just zoom in on a couple of them. If you look at this one, do you see the mud cracks? Pretty cool, huh? Let me show you another one. Saw a pretty good ripple mark up here. They're all over the place, you just have to get through them. They're red rocks, but do you see the ripple marks right here? Well, that's a different formation than what I'm standing looking at. That's the Grinnell Formation, but we're in the Helena Formation. But they've used rocks from all over, and this is supposed to stabilize a particular area, most likely because it's washed out into the road and done damage to the road. And I'm actually going to come in and show you a stormwater conveyance system they've built to help it drain better. So that very thing doesn't happen, keeping this road a little bit safer. So I'm going to cross the road and show you it's coming out this direction into that ravine right there and feeding into the valley. Welcome to Yosemite Valley, and this is in California. Yosemite is made up of gigantic monoliths of granite, and as you're taking this look at Yosemite Valley, I want you to notice that the stuff on the left-hand side is highly jointed. And jointing comes from pressure that's either caused by tension or release. Sometimes compression can cause joints as well. But nevertheless, these joints have occurred in Yosemite primarily because of isostatic rebound when ice after the last ice age melted, causing these fractures to form. So as these fractures release their pressure, the granite begins to peel off into layers. So the nickname for exfoliation domes is also referred to as onion skin weathering, but it is the primary mechanism by which mass wasting occurs in the park. So as we look at the type of rock that makes up Yosemite, it is granite and something like diorite, which is what you're seeing right here. But when you look at the big granite monoliths and sections like you see right here of a giant dome, These are the exfoliation domes. You don't see that same pattern unless you get up close and personal. So granite doesn't seem like the most usual choice for mass wasting to occur, but when it does, it comes out in very large chunks like you're seeing right here. So keep in mind that mass wasting always is not with sedimentary rocks like you might have learned as we were looking at part of Arches National Park. Well, as we were in Yosemite, we were driving through, and you'll notice the rocks on the ground there, and you can see that this came off of the walls of the exfoliation domes. The end result as these things peel off is this right here. You'll see a number of talus slopes which are made up of rock falls and rock slides that have come down the hills or down the sides of these exfoliation domes. So as you look at the next type of mass wasting, we can put some best management practices in to help reduce it. Best management practices such as this retaining wall and fence are simply there to try to help protect human health and the environment from any kind of rock slides or rock falls. There's signage everywhere that says landslide area, and I'm just going to kind of show you this is there to try to keep it out of the highway as much as possible. If you kind of look at the base, you're going to notice some rock clutter where it actually still has already fallen down. See if I can find it here for you. There it is. But that should be on a much larger scale, and this is just a small slope here. These are all over the place. To reduce the potential of mass wasting. This is a talus slope in the Mount St. Helens area, and in order to stabilize this volcanic material, they use something called rock bolts. So you can see that this is actually trying to protect a road, and it's actually still mass wasting on the ground. This is what it looks like up close and personal as we begin to get a profile right here, and all they've done is anchor in this retaining wall to try to keep mass wasting from influencing the environment and humans. So the signs you see along travel roads like this one should be a warning to you, because they're there simply because it's a risk for human health and the environment. When you look at something like this, you can see where mass wasting might occur, but right where you live, you might go, well, I'm not at risk. Never underestimate that mass wasting can happen anywhere to anyone at any time. Always know that humans and the environment are at risk for mass wasting. See you at the next stop. Bye.